The big ideas today were about how you subtract an integer and how division is related to multiplication and some special properties in algebra. So we started by seeing if you could write this subtraction problem as an addition problem. And a lot of you didn't know how, but we reviewed it, and remember to subtract an integer, you always add its opposite. So 4 minus 9, if I have 4 euros, I can't spend 9 euros without borrowing some euros. So this is like having 4 euros in your pocket and adding a debt of 9 euros. So I can spend those 4, but I need to borrow 5 euros. So 4 minus 9 is the opposite of 9 minus 4. 4 minus 9 is a negative 5. In general, to subtract a minus b, you take the opposite of b and you add it to a, and I'll show you that again in a minute. And then we started by rewriting this division problem as a multiplication problem. A lot of you didn't really understand that. This really is a fraction, but a fraction means division. 2 divided by 5. So 2 divided by 5 is like having 2 cookies. I divide each one into 5 equal pieces, and I take 2 of those. So here's 1/5. 1 out of 5 for the first cookie, 1 out of 5 for the second cookie, so I really have 2 groups of 1/5. 2 times a fifth is the same thing as 2 divided by 5. So these 2 parts make 2/5 of a cookie. So 2 cookies divided into 5 parts gives me 2/5 of a cookie, and that's 2 groups of 1/5. Remember, algebra is the language of generalizing. So in general, to subtract an integer, you add its opposite. So for a minus b, that equals a plus the opposite of b. So if I have 4 minus a negative 9, this becomes 4 plus, this subtraction becomes addition, and I take the opposite of negative 9, which is a positive 9. So this becomes 13. 4 plus a negative 9 becomes negative 5. There should be a negative sign there. So again, just like 2 divided by 5 becomes 2 groups of a fifth, in general, a divided by b is equal to a groups of 1 out of b. The denominator is the size of your piece. So if I have a candy bar that I split into 5 parts and I get 2 of them, that's 2 parts out of 5, or 2 groups of 1/5. So the size of your piece times the number of pieces. And remember, you cannot divide by 0, because there's no number that when I multiply by 0 I could get 6, because anything times 0 is 0. So dividing by 0 is called undefined. You can study those properties on page 7. So I said try it. So how is 5 divided by 12 a multiplication problem? So if I have 5 divided by 12, if I have 5 cookies, and I divide each of them into 12 pieces, okay, I've got 5 groups of 1/12. So 5 divided by 12 is the same thing as 5 times 1/12. 12 subtract 17 is like 12 plus a negative 17, which is negative 5. And then Alyssa asked, well, what about if the first number is bigger than the second? Same thing. 17 minus 12 is the same answer as 17 plus the opposite of 12. That's still 5. So it works with either way. In your graphics calculators, I taught you how to use the exponent key. So literally, if I want to know what 5 squared is, I put 5, I hit this button, x squared, and I get 25. Then you tried it for 18 squared. 18x squared gave us 324. 2.5 squared, hit the x squared button, gives you 6 1/4. And then we use the exponent key. So this little key that looks like a tent above the division key is an exponent key. So if I want to know what 5 cubed is, remember 5 cubed means 5 times 5 times 5, I can just use the tent key, the exponent key, 5 raised to the 3rd power, and I'll get 125. Then you tried it. 12 raised to the 4th power, which remember means 12 times 12 times 12 times 12 is 20,736. And then the square root key, we use the second function, the blue key, with the x squared. If you look above the x squared key in blue, it says the square root, and the second function key is the same color. It's blue, this is blue. Second function just means that not only can that key give you a number squared, but it has another purpose, another function to it. And if you hit the second key, you get what's above that, which is the square root. So if I want the square root of 1,156, I hit the second function key, x squared, put in 1,156 and press equals, and I get 34. And this means that 34 times itself gives me 1,156 as a product. Then you did one on your own. Second function of x squared, 625, gives us 25 because 25 squared is 625. Another way to generalize in algebra is formulas. Formulas using measurement and geometry. So to find the volume of this prism, it's length times width times height. But remember that multiplication is commutative, so I can do that in any order. So I can do 15 times 20 times 10, or I can do 20 times 10 times 15. Either way, I could fill this prism that had these dimensions with 3,000 little cubes that are each a centimeter on a side. So we were reviewing this just to talk about the groupings, because that leads to another property in algebra, the associative property of multiplication. So we looked at this prism. I can do 20 times 10 first and get 200 and multiply by 15 and get 3,000. Or I can move the brackets and put them around the 15 and 20 and get 300 first times 10, and I still get 3,000. So because a group belonging to a group like the National Basketball Associations, a National Basketball Association, an association means a group. So the associative property means that you can change the brackets, the groups, and it doesn't change the product. So in general, the language of algebra, remember the order is the same, A times B times C, A times B times C, but in this one I'm going to group B times C first, then times A, and this one I'm going to group A times B first, then times C. I will get the same product. It doesn't matter if it's all multiplication and I move the brackets, I change the groups, the product is the same. Okay, so that's the associative property of multiplication, and we also discussed that it also works with addition. If I have 2 plus 5 grouped together and add 3, I get 7 and 3, which is 10. And all I did was move the brackets. I still have 3, 2, 5, 3, 2, 5. So if I group together 3 and 2 first, I get 5, and 5 and 5 is 10. So it also works. One more important property was the transitive property of equality. And what that means is if 2 times 5 is the same as 2 plus a negative 5, and 2 plus a negative 5 gives me negative 3, then 2 minus 5 is also equal to negative 3. In words, it's kind of like if Alyssa equals 14 and Diana is the same as Alyssa, then Diana is also 14, with just logical reasoning with words. So then we practice some. So all we did was move the brackets here. It's all multiplication, so this was the associative property of multiplication. And then this one you had a little bit of a harder time, so we just looked at this fraction. 63 225ths is the same as 7 25ths, and 7 25ths is the same as 28 hundredths. And my question was, what can you conclude? So if this is A, if A is equal to B, and it is, and because I can divide each of these by 9 and I get to 7 25ths, and then this same number, 7 25ths, is equal to C, B is equal to C, 28 hundredths, multiply 7 times 4, 25 times 4. What I can conclude is that this 63 225ths is equal to 28 100ths. That's the transitive property of equality. And we just did a quick check. We changed each of these to decimals, and all of them are 28 hundredths. All right, and then just a reminder that you guys have to show me your binder every class time. You must show me your paper and pencil work. That's 3 points for a grade. That is your evidence that you did the paper and pencil math that goes with Alex. And you must, even though it's 4 hours a week and 20 topics a week, you must not wait till the end of the week to do it. Every time I see you in class, you have to have put in some progress. Okay, then we corrected your homework. And then for homework, you need to keep working on Alex. Show me your work in your binder. You'll get an assessment automatically. It should come up this week if you put in the time. So what you need to do in your algebra work is just a little bit of work. Pages 11 to 12, numbers 12 to 14, numbers 16 to 17, number 20, and numbers 26 to 29. Number 30 is an extra credit. Just show me all your steps. It's really an excellent problem solving. Look for a pattern. Use guess and check. Organize your guess and checks in a table. and I'll collect that from you next class. And then just remember, every class you need to have a fully charged laptop so you can work on ALEKS in class for part of the block, and every class you need to show me the paper and pencil work that you've done. And that's it. So have a great evening.